Hello everyone. Welcome back to my course Aerospace Engineering, Avionics and Aerospace Systems. In this video, we will talk about the general description of hydraulic systems. Also, I would be thankful if you give me feedback about this course to make it better and more useful for you. Please write down your thoughts in the comment section or reach out to me via the email provided in my profile. Purpose and importance of hydraulic systems in aviation. The ATA chapter of hydraulic system is 29. Aircraft hydraulic systems are essential for powering and controlling many critical components and operations on modern aircraft. They are designed to transmit force using pressurized fluid, which allows for efficient, reliable, and powerful movement of various systems. The importance of hydraulics lies in their ability to provide the force needed to operate major flight control surfaces, landing gear, braking systems, and more, all within the constraints of limited space and weight in an aircraft. Advantages over mechanical and electrical systems. Hydraulic systems offer several distinct benefits compared to mechanical and electrical alternatives. They are capable of delivering high power through relatively small and lightweight components, which is particularly valuable in aviation. Mechanical systems, with their complex linkages, tend to be bulky and wear out over time. Electrical systems, while useful for certain tasks, can be limited in terms of the power they can deliver reliably. Hydraulics, on the other hand, provide smooth, precise, and consistent motion, even under heavy loads or extreme environmental conditions. They also tend to be more durable and require less maintenance over time. Overview of hydraulic-powered functions. A wide range of aircraft systems rely on hydraulic power to operate effectively. These include both primary and secondary flight controls, such as ailerons, elevators, rudders, and spoilers, which are critical for maneuvering the aircraft. Hydraulics are also used to extend and retract the landing gear, operate the wheel brakes, and deploy wing flaps and slats that assist with takeoff and landing. In larger and more complex aircraft, additional hydraulic applications include the actuation of thrust reversers, cargo doors, and even utility systems like cabin door mechanisms and ramps in military transport aircraft. Basic system flow, from reservoir to actuator. The operation of a hydraulic system follows a closed-loop flow. It starts with a reservoir, which stores the hydraulic fluid and supplies it to the system. The fluid is drawn into a hydraulic pump, which is usually powered by an engine or an electric motor. This pump pressurizes the fluid, which then passes through filters to remove any contaminants. Next, the fluid is directed by selector valves to the appropriate actuators, which may be hydraulic cylinders or motors. These actuators perform mechanical work, such as moving a control surface or deploying the landing gear. Once the fluid has completed its task, it flows through return lines back to the reservoir, ready to begin the cycle again. System safety, reliability, and redundancy principles. Hydraulic systems in aircraft are built with a high emphasis on safety, reliability, and redundancy. To ensure continuous operation, even in the event of a malfunction, aircraft are typically equipped with multiple independent hydraulic systems. This means that if one system fails, others can take over to power essential functions. Components such as pressure relief valves, isolation valves, and accumulators help maintain safe operating pressure, isolate damaged sections of the system, and store emergency power. Additionally, aircraft often have backup systems like electric pumps, air-driven pumps, or ram air turbines, RITs, to maintain hydraulic pressure during power loss. leak detection systems, and fault-tolerant designs further contribute to the overall safety and reliability of these critical systems. Okay guys, now let's have a little quiz. The quiz consists of 3 questions. I'll give you 10 seconds for each one, and then I'll show you the correct answer. Let's start with the first question. Question 1. What is the primary reason hydraulic systems are used in aircraft? The correct answer is they transmit force efficiently. Question 2. Which of the following is a key advantage of hydraulic systems over mechanical and electrical systems in aviation? The correct answer is high power with lightweight components. Question 3. What component stores hydraulic fluid and supplies it to the rest of the system? The correct answer is reservoir. Unlock the world of aerospace engineering with 2 of my other expertly designed courses. In Aerospace Engineering, Basics of Aviation Engines, you'll explore the different types of aerospace engines and how they perform, giving you a strong foundation in propulsion systems that power modern aircraft. Then, take your knowledge to new heights with Aerospace Engineering, Aerodynamics and Structures, where you'll dive into the design and performance of aerospace structures and their aerodynamic behavior. Whether you're a student, aspiring engineer, or aviation enthusiast, these courses will equip you with essential knowledge to understand and contribute to the future of aviation. Join hundreds of learners and start building your aerospace journey today. Thank you guys for watching this video. If you have any questions about this lesson, feel free to ask me in the comment section. I will answer as soon as possible. We can continue to the next lesson and learn about basic principles of hydraulics. See you in the next video. Bye.